3M, we're going to solve some problems with parabolas today. So we have a rock that's thrown into the air from a bridge and falls to the water below. The height of the ball h meters relative to the water t seconds after being thrown is given by h equals negative 3t squared plus 9t plus 30. So things that I know it's upside down because there is a negative for A. I know that it's relatively skinny, whatever that means. The only thing that this form tells me otherwise, because this is standard form, is the y-intercept. So standard form will tell me that initial value on the y-axis, and it is a value of 30. So since height is in meters, we know that this would be 30 meters. Coincidentally, the first question we're asked is, how high is the bridge above the water? So the initial value is when it's thrown from the bridge, so that bridge is 30 meters high. Now we go on and ask you some other questions. After how many seconds does the rock hit the water? So if we were to draw a graph of this, we know it's upside down, and we know the y-intercept is 30. We would have x-intercepts here and here. Now I drew that with dotted line on the side because this x-intercept doesn't make sense. But we would have another x-intercept over here. And if we're asked after how many seconds does the rock hit the water, I want to know the x, or in this case, t-intercept. Remembering that we could get two answers. One of them might not make sense because you can't have negative time. So we'll have to be careful with our answer. So I wrote my equation again to work with it on this page, but this form doesn't tell me the x-intercepts. So I am going to change it to factored form, which will tell me the I keep calling them x-intercepts, t-intercepts in this case. And what I have to do, and not trying to be sarcastic, but what I need to do is to factor. So here's my checklist. Is there a greatest common factor? What do you know there is? So I'm going to take out a common factor of negative 3 so that that first term t squared will be positive. Negative 3 times what gives me 9t? Well, I need 3 and I need t. It will be negative, so that when I multiply, I get positive 9t. Negative 3 times what gives me 30? I will need negative 10. Do a quick distributive law in your head and make sure you get what you started with, especially the positives and negatives. My next line would be, can I factor this any further? So I'm considering a difference of squares or simple trinomial. This one has 3 terms. I'm hoping it will factor nicely as a simple trinomial. So factoring it, I would have a t at the beginning of both brackets. I need 2 numbers that multiply to 10 and add to negative 3. So I need a 5 and a 2. That's the only way to get to 3. My larger one will be negative, so that I add to negative 3, positive 2. I have fully factored that. That tells me my 2 t-intercepts, and if you recall, it will be positive 5 and negative 2. If you forget, you can set any one of those brackets equal to 0, and that will give us a 0 for the equation. Because our y-intercept is 0 at the t-intercepts, I would get a value of t equals 5. Or for the other bracket, t plus 2 equals 0, I would subtract 2 from both sides, and those are my 2 t-intercepts. That tells me on my graph I have a t-intercept of negative 2 and a t-intercept of 5. The negative 2 doesn't make any sense. So after how many seconds does the rock hit the water? It hits the water after 5 seconds. Okay. Next question says, Sally is standing at the top of a river slope and throws a ball. The height of the ball at a given time is modeled by the function h of t, so there's our function notation. Negative 5t squared subtract 10t plus 250, where h of t is the height in meters and t is the time in seconds. When will the ball be 10 meters above the ground? What do I know about this function? I know that it's upside down. It was relatively skinny. It has a y-intercept of 250. So that is the only point that I know, 250. When will the ball be 10 meters above the ground? Okay, let's draw just a really rough graph. So the ball is thrown from this high river slope. It's a strange question, isn't it, when it's 250 meters in the air for a river slope. But anyways, she throws it, and we're going to have one of these, or you're probably going to have a t-intercept that doesn't make any sense. And we want to know when, so I want a t value, when will the ball be 10 meters above the ground? So when will it be here? I would really like to know that value. I don't care about here because that doesn't even make sense. But I want to know when the t value is 10. We have two strategies. We can use a graphing calculator. And I would like to do that in class because it's given me a little bit of trouble tonight. Or we can do it algebraically if the numbers are nice. So let's give it a go. I want to know when h of t is equal to 10. So I'm going to set that equation equal to 10. When is 10 equal to my parabola? Now it is possible that it is not a very nice value for t. We have no idea. So we're going to try our best, and if we fail, then we're going to try this graphing calculator again. So I don't know how to solve something like that. I am going to get it into a form that I know, however, because I'm not used to having a number on one side and this quadratic equation on the other. So I'm going to subtract 10 from both sides. And now I have 0 equals negative 5t squared subtract 10t plus 240. I have two options if I want to find my value for t. I could try and factor. I could use the quadratic formula. I'm going to try and factor first. I'm looking for a greatest common factor. It looks like 5 will go into those terms. T squared. I need positive 2t. And 240 divided by 5 should be 48. And I need a negative so that a negative times a negative is a positive. I want to factor this, hoping it's a nice simple trinomial where I have t at the beginning of both brackets, two numbers that multiply to 48 and can add to 2. Well, I know 6 and 8 can multiply to 48 and are 2 apart. So I want my larger one to be positive so that it will add to positive 2. I have my two t values, t equals 6 or t equals negative 8. So the negative 8 one doesn't make sense in this problem, but after 6 seconds, that equation is equal to 10. We have solved our problem by factoring.